Hi to all. Hope all are doing well. Stay home, stay safe. But as the time running out, we have to have some discussion regarding our remain syllabus. Today, our topic is next topic. Now we are discussing about beta-lactam antibiotics. That beta-lactam antibiotics, we had already finished some topics like penicillins completed. Next topic is cephalosporins. I have already given the required material, what is required for the preparation of this. These are also beta-lactam antibiotics. Already you know what are beta-lactam antibiotics. The beta-lactam antibiotics containing beta-lactam ring in their structure. When you study regarding chemical structure, you will find a beta-lactam ring which is present in the structure of penicillin antibiotics. See, the cephalosporins and cephamycins, these are beta-lactam antibiotics. First, they are isolated from one fungi. This is just a small introduction regarding cephalosporins. These are the first classification. These cephalosporins are classified mainly based on the time of discovery. Okay, it means they are mainly classified into 5 classes of drugs. They are first generation cephalosporins. These first generation cephalosporins also again has been classified into 2 types: parenteral, by the route of administration they are classified into parenteral route and oral route. Means parenteral in the form of injections, they are mainly given in the form of injections only. So for the first generation cephalosporins, the parenteral are cephalothin, cephalexin. Already in the classification, already in the material I had given, the first generation parenteral drugs are cephalothin and cefazolin. For oral drugs, cephalexin, ceftriaxone, cephadrine. And next, second generation drugs, third generation, fourth and fifth generation cephalosporins are there. Okay, regarding this classification I had given in that PDF material. You will go through that classification purpose. Okay, so after this, some of the semi-synthetic broad spectrum. See, broad spectrum are most important because they have wide spectrum of activity. So broad spectrum cephalosporins have been produced by addition to the cephalosporin nucleus of different side chains. Already we have discussed regarding this nucleus, which contains R1 and R2 side chains. If you will add different types of chemical constituents, functional groups to this R1 and R2 side chains, they will produce different types of cephalosporins. Especially semi-synthetic broad spectrum cephalosporins have been produced by this addition. Okay, so and one more property of cephalosporins is that these cephalosporins are water soluble and relatively compared to penicillins, these are somewhat acid stable. Okay, and these cephalosporins also showing varying degree of susceptible. They are mainly susceptible to one enzyme. Already you know the beta lactam. All beta lactam antibiotics are mainly susceptible to one enzyme, that is beta lactamase. This beta lactamase enzyme specifically breaks one bond. I had already given the full information regarding the beta lactamase enzyme, where it will break the bond, all those. Okay, so these cephalosporin is also susceptible to the beta lactamase enzymes. And as of now, whatever the reason it is, many cephalosporins and cephamycins are now available for the clinical use. Okay, but like all other antibiotics, these cephalosporins also having one problem, that is resistance. Already you had discussed some antibiotics like sulfonamides, penicillins. All these drugs are having resistance problem. Like this, these cephalosporins also uh, facing the problem of resistance. So the resistance is mainly produced against these cephalosporins by the resistance is increased, being the method of plasmid encoded or by the chromosomal beta lactamases. So preferentially, these beta lactamase enzymes attack on specific bonds of the cephalosporins, and these bonds will be destroyed. Because of this destruction, the activity of the cephalosporins will be decreases, so which causes one of the type of resistance. So but the substance which causes resistance is chromosomal beta lactamase. These chromosomal beta lactamase are present nearly in all gram-negative bacteria, and it is more active in hydrolyzing the cephalosporins than the penicillins. Especially chromosomal beta lactamase enzyme causes hydrolysis of cephalosporins higher amount compared to penicillins. Okay, so that is why this enzyme causes high amount of resistance in cephalosporins. Okay, next mechanism of action. Okay, so already you know the basic principles of chemotherapy. Only we have discussed different targets useful for the chemotherapy. So already the targets, biochemical reactions we had discussed, class 1 reactions, class 2 reactions, class 3 reactions, and formed elements, all this. So in class 2 reactions, mainly we have discussed about peptidoglycan synthesis. Okay, so this peptidoglycan is mainly present in the cell wall of bacteria. Okay, for the formation of cell wall, additional protection cell wall, the peptidoglycan synthesis is very much essential. Already we have discussed each and every part of the peptidoglycan synthesis. Okay, it is having one problem of transportation through narrow spaces present in the cell membrane. That is why it is required a C55 lipid carrier molecule that is useful for the transportation of the peptidoglycan from the inside of the nucleus to the outside of the cell membrane. That all we have discussed. Okay, so as like penicillins, these cephalosporins also disrupt disrupt the synthesis of peptidoglycan layer. Disrupt the synthesis of peptidoglycan layer, which is essential for the formation of cell wall. Okay, so what happened where it will disrupt is, already we had discussed in the peptidoglycan synthesis, the final transpeptidation step is very much essential. Means after the formation of the all the building blocks of peptidoglycan by the N-acetyl glucosamine and N-acetyl muramic acid. These two building blocks are joined. Already we had discussed each and every step. And after the formation of total peptidoglycan, it has transported out of the cell membrane. From this inside of the cell, it is transported outside of the cell membrane to form the cell wall. Where it will form the cell wall? Here, this peptidoglycan building blocks, they are come and attached to the previously transported peptidoglycan. Okay, so between these two different building blocks, one bond is formed, that is called transpeptidation. Peptide bond is formed between them, that is called transpeptidation. Okay, so this step, transpeptidation, is inhibited by the cephalosporins antibiotics. Okay, so because of this, the formation of the cell wall will be decreases, means the integrity of the cell wall will be decreases, which causes disruption of the cell wall. So whenever the cell wall is disrupted, the growth of the bacteria is inhibited. Okay, so because of this, the bacteria will be died. So this is how the growth of the bacteria is inhibited by using cephalosporin antibiotics. Okay, so especially in the transpeptidation step, but where these drugs will bind, mainly they will bind to penicillin binding proteins. Already I had discussed regarding these substances also. These are present in the bacteria. So the penicillin binding protein binds to the DLR end. Already we have no DLR end. The chain contains this sequence DLR end of the neuropeptides to cross-link the peptidoglycan. Okay, so this cross-linking will be inhibited. Okay, so means all these beta-lactam antibiotics are having similar structure to the DLR chain. So because of this, the penicillin binding proteins mistakenly recognize the cephalosporin antibiotics as this chain. So they will bind to these penicillin binding proteins and inhibit the penicillin binding proteins. Because of this, the cross-linking will be inhibited. Okay, this is how the peptidoglycan synthesis is inhibited, which causes disruption of cell wall. Hope all are understanding well. ఎందుకంటే ఇంతకుముందు క్లాస్లోనే మనం మొత్తం చెప్పేసినాం. ఆ బ్యాక్టీరియాని చంపేయాలి. మనం ఇన్ఫెక్షన్ ఇచ్చిన బ్యాక్టీరియాని చంపాలంటే దానికి సెల్ వాల్ రక్షణ కవచంగా ఉంటుంది. ఆ సెల్ వాల్ని మనం ఇచ్చే యాంటీబయాటిక్ పెన్సిలిన్స్ కానీ సెఫాలోస్పోరిన్స్ కానీ ఇవేం చేస్తాయి, ఈ సెల్ వాల్ ఫామ్ అవ్వకుండా ఏదో ఒక స్టెప్ ద్వారా ఇన్హిబిట్ చేస్తాయి. అన్ని స్టెప్స్ మనం డిస్కస్ చేసినాం కాబట్టి క్లాస్ 2 రియాక్షన్స్లో. Here these cephalosporins are specifically inhibit the transpeptidation step. Especially the penicillin binding proteins are misrecognized these, and which causes disruption of the bacteria. This is the mechanism of action of cephalosporins. See, all the drugs which are comes under cephalosporins are having same this mechanism of action. There is no specific mechanism of action. The drugs which are discussed under cephalosporins are all having same mechanism of action, as well as same pharmacokinetic properties and same clinical uses. That is why if you have to read one pharmacokinetic properties, you have to use for all the drugs. Okay, so pharmacokinetic parameters. So this already in the classification as you had written parental oral route. Okay, so some cephalosporins, some pk parameters, some cephalosporins given by oral route, but most of the cephalosporins are given by parental route. Parental route means mainly intramuscular or intravenous injection, IM or IV injection, intramuscular or intravenous injection. Okay, this is about route of administration. Next, absorption. uh, they are easily absorbed. After absorption they are widely distributed in the body, and they can cross the blood brain barrier easily. Okay, next, excretion. Excretion is mostly via kidneys. Excretion is mostly via kidneys, largely by tubular secretion, but 40% of ceftriaxone is eliminated in the bile. Through liver it is eliminated. Okay, these are the pharmacokinetic properties. Next, clinical uses, very very important. As like penicillins are some clinical uses most important. Here also cephalosporins clinical uses. Mainly these cephalosporins are used to treat infections caused by sensitive organisms with other antibiotic patterns of sensitivity. There are mainly many different kinds of infections are treated with these cephalosporins. They are including mainly septicemia. Septicemia, mainly two drugs for septicemia. Two drugs, septic, simply called septic. If it is causes septicemia, mainly two drugs are used. Cefuroxime, in the classification it is there, cefuroxime. Then cefotaxime. Cefotaxime. Okay, septicemia. After septicemia you can use these drugs mainly in case of pneumonia. Pneumonia, నిమ్మొచ్చింది అంటారు కదా, అది pneumonia. The next, pneumonia, meningitis. Meningitis, pneumonia, meningitis. Next use is biliary tract. Biliary tract infections. Biliary tract infections. Okay, next, urinary tract infections, UTIs, urinary tract infections, especially when pregnant women are infected with the urinary tract. In that conditions cephalosporins are used. Next, sinusitis. Sinusitis, in case of sinusitis also cephalosporins are used. These are the major clinical uses of cephalosporins. Next, unwanted effects. Unwanted effects, mainly hypersensitivity reactions. Hypersensitivity reactions, about 10% penicillin sensitive individuals will have allergic reactions to cephalosporins also. And one more unwanted effect is nephrotoxicity. Nephrotoxicity, and sometimes it causes diarrhea. 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 Especially it occurs mainly with cephalosporins and cephalosporin drugs. Okay, students, this is about cephalosporins. There is nothing much to discuss in regarding this. And whatever I had given, that is sufficient. Please go through that. If any doubt, ask me without any hesitation. I am ready to clear your doubts. Thank you.